All right, this is part 3 of experimental spaceship material, this time versus the blowtorch. You see I got the blowtorch right there? Yeah, buddy. Got the blowtorch. All right. I'm serious now about this kind of stuff. I'm gonna find out what happens. All right, so I'm using a lighter that I smoke with. See, that's my cigarette. So it's my first one I did, the second video, and that's the third video cigarette. I'll finish them later. Got my piece of paper. I got my lighter. And I'm not using the lighter at the blowtorch. I got the what you call it going right now. It's on. You can probably hear it hissing. Hear it? Anyway, so it probably needs to be turned down a little bit. It's a little bit high. Not supposed to be that high. Okay, it's lower. So I'm going to use the piece of paper to light it, because if you use a lighter that you smoke with, the gases and stuff, because when the flame goes up, it doesn't just go up, it goes up and around. It creates currents. So that means that the odor from the torch will get sucked into the lighter, and then your cigarettes will taste funny. So I'm going to light this paper and quickly go over here and light this torch. All right, we got a fire. Let that simmer. Shouldn't go nowhere. It'll burn, but all right, just kind of ignore it for right now. And put it over here somewhere so it can smoke me out. I don't know where to put it. Damn. We'll just put it somewhere. We'll leave it right there. I'll watch it. Watch it for me, y'all. Okay, so I've got the torch burning. Set a low flame, and let's turn it up just a little bit. Now here's the thing, my tip is messed up. I let this thing stay outside and the weather got to it, so the tip isn't as it should be. It's not. It's more like a lighter. It's not doing what it should. I could turn it up on the main tank over there, but it's still just not going to do right. So we're just going to use the flame just like it is. All right, so this is what happens. We know it's got glue concentration mixed into it. It's burning. Yeah, it's burning. So the glue is burning. This is why I talked about adding something to it so that the glue doesn't burn. Let's see, I'm gonna get it going really good. Now mind you, it's not much glue in this. So I wonder if the glue burns out, do you have the concrete left behind? Of course. But I just want to see what it's like. It didn't burn that much. See what it did to it? It's not really sustaining a burn. So we've got a material here that will burn, at least that top surface. What if the concrete acts as an extinguisher a little bit? So that's heat right up against it. Let me turn this flame up a little bit. Okay, here we go. It caught fire on the edges, but it's not fully burning. Fam, I'm not seeing the change. Remember what I was saying about heat dissipation? It's like 94 out here today, and it's cool to the touch. when I took it out of the house, of course. I guess it'll be like room temperature, but what I'm saying is, I think it has its own heat dissipation that's going on right now because of the concrete. So putting the flame directly on it, oh look, it did scorch it some, right there in the middle. See in the middle? Let's keep the flame on it right there. It's lightening up, oh, it's burning on the edge over there in that top left corner. It was burning, it's still burning. It's catching. Let's take the flame off, see what happens. And it stops. So it needs a constant source of, you have to be exposed to a constant flame in order to keep going, but I'm thinking the concrete is acting as a natural extinguisher. We'll just have to find a way to keep the concrete together no matter how much heat is applied to it. And you can see I'm trying to concentrate the effort right there. And it's doing pretty damn good. Knowing that there's a glue mixture in it. This is wood glue, by the way, mixed in with concrete. It's doing pretty damn good. I mean, that's a direct flame. It's not a nice flame like you get from a torch that has a good tip, but it's a flame. See, that's the kind of flame it's putting out. The tip's not good right now. It's weathered. But look how well it's withstanding heat. So if it can withstand heat from a fairly big flame like this, in the natural environment under hot sunny conditions, this material should last a long time. Now, the next question is pressure. Can this hold air pressure like a balloon? Now, I know it's not dense enough, but I could probably get the density up by adding something to it other than glue. I just don't know what right now. Now you saw that. The edges did catch on fire, but it went out. I may not have to worry about a flame retardant material chemical, because, and I do smell it burning. It's not very strong, or it could be the paper right there burning. That's what's burning. That's what's burning. Paper. Fam, it's holding up pretty good. But that's with a little bit of glue and a lot of concrete. And this is the top side where most of the glue is at. It's catching on the very edges because that's purely glue right there, mostly. But it won't stay lit. It burns under a flame, but extinguishes. I like that. All right, so let's put this right here. Hope it doesn't slip and fall and burn my pants leg up. All right, let's see what it feels like. I can touch it. It's very warm, and yeah, it's kind of still, it holds temperature. It's hot. To the finger touch, it takes a second to feel it. It's like the heat has dissipated. It's gone into the material and spread out. So if I had a wire mesh mixed in here, it would spread out even greater. And this is thick material, so imagine making it thinner, stronger with the wire mesh in it. The heat would dissipate much more than this. Now I can kind of lay my fingers on it for a few seconds. The edges pretty much turned into charred material. All right, and this is kind of a no-brainer on the other side. What's going to happen? Probably nothing. But let me see. So right there where I've got that broken up spot, we know that's mostly concrete. But let's see what happens when we put a flame to it. And it's still wet, by the way. Still wet. But I'm gonna put this down into it. I'm looking through the camera. Let me look over the top of the camera and see. I see no changes whatsoever. No change. No change. Nothing burning whatsoever. So that makes me wonder if I retain a little bit of the moisture in the concrete. Let's say if I sandwich this material in between plastic. Keep it moist, fire resistant, or at least just sandwich a backside of it. Like, let's say the top side is going to be what it is, and the other side is going to be something else that retains moisture. Then you have an automatic fire retardant. Exactly. It's not burning, y'all. It's just a flame. I guess the gases are being trapped, and it's just flaming up like that. No effect whatsoever on this side. No effect. It's not doing anything to it. Nothing. Maybe a tiny bit where the glue is concentrated, but that's not much at all. But the idea is to hold this concrete together in such a way where the glue doesn't burn that much. The heat is dissipated. It puts itself out if it's put on fire. Now, I guess what just popped into my head was just what would happen if you poured gasoline on it. I don't know. And I don't have any gasoline right now to pour on it. It looks like it's starting to make it dry. Look on the very edge right there. In front of the torch on the very edge at the top. It's starting to dry. It's not burning, it's just sort of drying a little bit more. You can see it changing color. So, that's about it. Let me go ahead and cut this off. That's the experimental spaceship material. It is holding heat. I feel it. It's radiating heat. I feel it. Feels like a coal, like hot coals. But I can touch it. And now, mind you, this is a lot of. It's very thick, so it's going to hold heat. But I can touch it. About that long. About that long. That's how long I can touch it without taking my finger off of it. So it cools down pretty quickly. So this is a thinner material, stronger, and able to dissipate heat better. It wouldn't hold temperature that long at all. And that's my goal. So this is the, this is the material I guess we can start experimenting with. Because, you know, wood is kind of expensive. You have to buy wood. This is something you can make at home. And I just showed you that you can put a flame to it. You can put a flame to it, and it doesn't sustain burning. It did burn a little bit on the edges, but that's mostly glue right here. It did not stay lit. It's holding a shape. If we were to shape it with a wire mesh, it would retain its shape. As far as strength goes, I guess that depends on what other materials we can add to it. But, you know, there can be like an underskeleton type of material that can be added to give it its shape, to hold a strength, hold a particular shape. It wouldn't be just this by itself. It'll be this, and this will be the outer skin of it, and you have an understructure. Or this is going to be the outer skin. It's going to have its own internal structure that serves as a heat sink also, the wire mesh, the metal screening. And then whatever type of surface that this can be put onto and affixed to, glued, epoxied, screwed into with actual screws, anything like that. Or let's go super high tech and we weld it together with an ultrasonic welder. Has anybody ever seen that before? ultrasonic welder. It's usually used with welding aluminum pipes together, and other things. I've seen it used. It was like an ultrasonic welder to do what? Oh, it was used to squeeze a pipe together, an aluminum pipe to seal it. But I wonder if we can use sound to bring two pieces together and let it form together instead of any kind of glue. Now that's getting out there. I don't know if I have to find the resonant frequency of each and every. I have to find the resonant frequency of this if I were to join it with another piece of its equal density. And when it's going to be made smaller, the resonant frequency of the material is going to change. So the resonant frequency of the two materials would have to combine. You'd have to use the ultrasonic welder, whatever the harmonics is that can affect the two resonant frequency of the materials, to bring them together without having to glue it. Where does that knowledge come from? I just put it together. It's just things that you know, and you put it together in your mind, and it makes sense. It's simple logic. So that's it, y'all. Thanks for watching. Black Space Project, North America.